identify preorder sequence in binary tree. So for this problem, we are given an array of unique integers, so it is called preorder. So we're going to return true if it is the correct preorder traversal sequence of a binary search tree. So we are giving this preorder sequence, it is an array, and we are going to check if this preorder sequence is okay for a binary search tree. We are sure that if we are giving an array, it can be any different kind of trees. Yeah. But we want to make sure definitely this array gonna be a preorder. Even though this is a preorder, it can be any kind of differences, but it is also combined. But we need also to combine with the binary search tree. It's gonna be a binary search tree. So let me just use some examples to understand the problem. So if we are giving an array, so for example, it is just like 5 to 1. Yeah. So this is our array, and we are going to build a tree according to this array. And this array is a preorder array, and this array need to build a binary search tree. So first of all, we're going to have a root 5. Yeah, because definitely if this is a preorder, the first node must be the root node. And then it will go to the left, and then go to the right, because this is going to be the preorder. If we were to go to the right, is that okay? Because 2 is smaller, definitely we wanted to go to the left, right? Yeah. Now we have this value 1. Can we put 1 here to the right side? No, we cannot. Yeah, because this is not binary search tree. We cannot put 1 there. So instead we can put 1 here. Yes. Can we put 1 at the right side of 2? No, we cannot, because we want to build a binary search tree. So the final state is going to be like 5 to 1. So this is going to be the tree structure. Yeah. Now let's just use another example. So another example, maybe we're going to use a 5, 6, 7. So this is going to be our array. Yeah. So first of all, we're going to have the root node, and then we're going to have 6. Can we let the 6 go to the left? Yeah, because according to the preorder, first it will go to the left, but we cannot, so we let it go to the right. So this is going to be the 6. Next, we're going to have 7. Can we put 7 at the left side? Definitely not, because currently we are at this 6, because this is a preorder. This is the root node. We first go to the left. Can we put it to the left? No, we cannot, because 7 is more than 5. So we have to put it to the right. So 5, 6, 7. This is another binary search tree, and this is also valid. So now let's just use another example. So for this 5, 6, and 7, let's just put another node. Yeah. Now we have 5, 6, and 7, and let's add another node, maybe 2. So is this valid? Now after this 7, we will first go to the left and then right. Can we put the 2 at the left side? No, we cannot, because this is 5. So this value definitely gonna be more than 5, but 2 is smaller than 5. Definitely it's not possible. Yeah. Can we put 2 at the right side? No, we cannot. This 2 must be more than 7. Definitely we cannot. So this means if we find a value, our current value, it is this value, it is even smaller than our current value, this 5. Yeah. If this value 2 is smaller than our current value, smallest value 5, because 5 compared to 6 and 7, it's going to be the smallest value. Yeah. So if this value 2 is even smaller than this 5, because 5 is the root node currently, definitely we're going to return a false, because it's really easy to find a false instead of finding a true, because if it is not false, everything going to be true. So if we find a false, like this node 2, and here is 5, definitely it's going to be a false, so we're going to return the false. So what kind of a data structure are we going to use to solve the problem? So the easiest way is that we're going to use a stack. We're going to use a monotonic decreasing stack. Yeah. So for example, from the beginning, we're going to put the node 5. So let's just use this first example, 5 to 1 here. Yeah. So according to our monotonic decreasing stack, if this value is 5, so definitely it is okay. And we're going to put it inside of the stack. So for the next value, it is a decreasing, it is a 2. So we're going to put it inside of the stack, and the next value is 1. We're going to put it inside of the stack. So it's okay, because we didn't find a false. And this is our stack. It is a monotonic decreasing. So it's going to be a true for this case. Now let's just check the second case. So first of all, we're going to put the value 5. Yeah. Currently our minimum value, we're gonna set a minimum value variable. It's gonna be negative infinity. Yeah. So first of all, we're gonna check the first value. It's gonna be this 5. So we're gonna put it inside of the stack. So inside stack, we're gonna have a 5. Now we're gonna have this value 6. So what's gonna happen for this 6? Can we directly put it inside of the stack, because this is monotonic increasing? This is not okay. Definitely we want to keep a monotonic decreasing stack. So we're gonna pop out this 5, and we're gonna reserve a minimum value. So instead of a negative infinity, it's gonna be a 5. So the value is gonna be 5. After pop out this 5, we're gonna put the 6 inside. Yeah. So currently the minimum value is 5. It is okay. And inside the stack, we're gonna have a value of 6. Now we're gonna check the next value, next number. It's gonna be 7. Can we put 7 directly inside? No, we cannot. We have to pop it out, and then we're gonna put a 7. And currently our minimum value gonna be 6. Yeah, because currently this 2 actually we don't need to compare with 5. We need to compare with 6. Yes, I'm sorry for the explanation from the beginning. Actually, this 2 gonna compare with this 6, because that 5 doesn't matter because we already meet the condition. This 2 just needed to compare with 6. Yeah. Now we have the next value 2. So this 2 is okay because 2 is smaller than 7. Yeah, we want to put it inside of the stack. But before we put it inside the stack, we need to compare this value 2 with the minimum value. So 2 is smaller than the minimum value. Definitely it's gonna be a false, because this is our 6. Yeah, and this is 7. Definitely this 2, if we want to put it to the left side of 7, we have to compare with 6. And this 2 is smaller than 6, so definitely it's gonna be a false. Yeah, so this is why we can use the monotonic decreasing stack to solve the problem, because we only consider this 6. That is why we need to pop out this 5. And we always want to keep it monotonic decreasing. So this is why. Yeah, I think that's all about it. Because the minimum value gonna always record the minimum value we want to compare. And if this value is less than the minimum value, definitely we want to return false. And all other values, for example, the 7, we want to put it inside of the monotonic decreasing stack. Yeah, because it has already met the conditions for us. So yeah, so that's it. Now let's just write the program to solve the problem. So as I said before, we're going to prepare a monotonic decreasing stack, and we're going to prepare a minimum value. So the stack going to be empty, and the minimum value going to be negative infinity. Now we're gonna loop through the preorder array. So for in, I'm gonna use enumerate the preorder array. So I'm gonna check the value. So for this if this value is less than the minimum value, definitely I'm gonna return a false. Now I'm gonna check if there's something inside of the stack, and the preorder of stack -1. I want to keep a monotonic decreasing stack. So currently inside of the stack, or top of stack, if this value is more than my current number, yeah, normally, for example, on top of the stack, for example, this is a 6. Next, I want to find a value of 5. Yeah, but what about if it is a 7? Yeah, so this means if this value is less than the current value 7, I need to pop it out. Yeah. So I need to pop it out, and the number gonna be the stack and dot pop. Yeah. So this gonna be the number, and this number actually is my minimum number. I need to record this minimum number. Yeah. So according to the example, if I gonna report pop out this 6, actually this 6 gonna be my minimum number. So here is the 6, here is 7. So next, maybe it is 5. Yeah, or maybe it is a 2. It's gonna be a false. Yeah. And if we go out of the while loop, we want to put it inside of the stack. Currently, we need to put the index inside of the stack, or you can also put the number inside. It doesn't matter. But for me, if I'm gonna write a monotonic stack, definitely I want to put the index inside. Yeah, because it can avoid a lot of issues. Now I want to return a true if I didn't return the false. Yeah. Now let me just run it and submit it to check if it works. As you can see, it's pretty fast and it passes for all testing cases, and the time complexity is O(n), and the space complexity is O(n) as well because we used a stack to solve the problem. Thank you for watching. See you next time.